Now we'll see the inverse of a tan function. It's a tan function. Can you say what is the domain and range? Yes, tan function or tangent is defined from R minus set containing a x is equal to 2n plus 1 pi by 2 where n belongs to z. Right? Domain of this function is set of all real numbers, but you have to remove the multiple of pi by 2 because you know that tan can be written as sin by cos. Cos can't be equal to 0 and range of this function is set of all real numbers. To define inverse, we have to check whether the function is 1 1 or onto. Let me consider the graph of this function. It's a graph. So this is the axis. Let me consider this is 0 and this will be pi by 2. Then it is pi, 3 pi by 2 and here it is minus pi by 2. Then it is minus pi, minus 3 pi by 2 and so on. Here it is 1, 2, 3, 4. This is now minus 1, minus 2, minus 3 and minus 4 and so on. So now here x is equal to at pi by 2, multiple of pi by 2, the function is not defined, right? Let me consider at pi by 2, this is not defined. So we will consider the dotted line at pi by 2. Then at 3 pi by 2 is also not defined, right? So this is also not defined. The tan function is not defined at multiple of pi by 2. So minus pi by 2 is also not defined. So here minus 3 pi by 2 is also not defined. I hope you are understanding this one because x is equal to multiple of pi by 2. The function is not defined. So this is a, now we'll see what is tan 0. Tan 0 will be equal to 0, right? Here 0 to pi by 4. In between pi by 2, in between pi by 4 is there. What is tan pi by 4? Tan pi by 4 will be equal to 1. What is tan of minus pi by 4? It will be equal to minus 1. So graph of this function will be like this. This is a one line. Next it will be, the graph of this function will be like this and here it is, here this is the graph of a function. Here this is infinite, right? Here you could see this one. If I restrict the tan function is between minus pi by 2 to pi by 2. Here all the values are different. Here from 0 to all the positive values are included. From 0 to all the positive values are included, right? Here from 0 to all the positive values are included. It is infinite. Here from 0 to all the negative values are included, right? To infinite. So range will be between plus infinity to minus infinity. But at minus pi by 2 to and pi by 2 is not defined. So we can restrict the tan function is between minus pi by 2 to pi by 2. But this minus pi by 2 and pi by 2 is not included. So the function tan can be restricted from the interval, open interval, minus pi by 2 to pi by 2 to r. Is it clear? The function tan can be restricted to minus pi by 2 to pi by 2 to r. Here minus pi by 2 is not included. This is the open interval. Here plus pi by 2 is also not included. So this is the open interval. So this is the domain of a tan function, restricted domain of a tan function, and this is a range. So in this function you can see this is 1 1 and on to, right? All the distinct elements will maps to a distinct one, right? So it is 1 1 and on to. So we can define the tan inverse, that is from set of all real numbers to open interval minus pi by 2 comma pi by 2. This is the domain of a tan inverse function and this is the range of a tan inverse function. Now we will see the graph of a tan inverse function. Let me consider the axis. Here this is 0 and this is real numbers means 1, 2, 3, 4 and so on. Here it is minus 1, minus 2, minus 3 and so on. Here it is pi by 2, right? And this is pi, then it will be 3 pi by 2 and so on. Here it is minus pi by 2, then it is minus pi, minus 3 pi by 2 and so on. And you know that at pi by 2 the function is not defined. Multiple of pi by 2 and multiple of pi by 2. So at pi by 2 this is not defined. At 3 pi by 2 is also not defined, right? At minus pi by 2 is also not defined and minus 3 pi by 2 is also not defined, right? Don't worry about these graphs. Actually these are not that much important, but you should know about this. But the domain and range of a function is very important. Without those, you can't solve the problems. Okay. Now we'll see this one. What is tan inverse of 0? It will be equal to 0. So the graph of this function will be like this. And here it will be, here it will be like this. This is the graph of a tan inverse function. Next we'll see the graph of a last one, that is chord function. Now we'll see the inverse of a last function, that is chord function. Under the chord function, can you say what is the domain and range? Chord, set of all real numbers. But what we have to remove from this? Chord can be written as cos by sine. So sine can't be equal to 0. So you have to remove set containing a x is equal to n pi, where n belongs to z. This is the domain of a chord function. To the range is the set of all real numbers. Same as in the earlier functions, to find the inverse of function, we have to check whether it is 1, 1 and onto. We'll consider the graph of this function. So this is 1, so this is now 0, and this is pi by 2, and this will be pi, then it is 3 pi by 2, then it is minus pi by 2, and here it is minus pi, and it is minus 3 pi by 2, and 0, 1, 2, 3, 4, and here it is minus 1, minus 2, minus 3, and so on. Where it is not defined, x is equal to n pi, multiple of pi. So at 0 the function is not defined, so this should be in a dotted line. At pi is also the function is not defined, right? At pi is also the function is not defined. Then 2 pi is also not defined. Here minus pi is also not defined, right? So we'll draw the graph of this one. Now at chord pi by 2, chord pi by 2 will be 0, right? Chord pi by 4, this is 0 to pi by 2. In between, half of this pi by 4 will be there. It is 1, right? So the graph of this function will be like this. Next it is here, the graph of this one will be like this, and it is continuous. This is the graph of a chord function. You can see this. In this the function is not 1, 1 and onto. But what we can do, if we restrict the function is between 0 to pi. You see here, if you restrict the function is between 0 to pi, all the positive values are there here and all the negative values are there here. It is from plus infinity to minus infinity. But here 0 is not included, as well as pi is also not included. So the function chord can be restricted from 0 to pi. It is open interval 0, pi, and all the values in between 0 and pi, but 0 is not included, as well as pi is also not included. 0, pi to set of all real numbers. This is the restricted domain of a chord function. In this you could see here the function, all the values have a different images. So the function is 1, 1 and onto. So now the inverse of this function is can be defined. Chord inverse will be a function from set of all real numbers to the open interval 0, pi. Open interval 0, pi. Now we'll see the graph of this chord inverse function. Let me consider the axis. Y-axis. Here set of all real numbers 0, 1, 2, 3, 4 and so on. This is minus 1, minus 2, and this is here pi by 2, pi, 3 pi by 2, and this is minus pi by 2, minus pi, and minus 3 pi by 2. Where it is not defined, at the value of multiple of pi. At 0 this is not defined, right? At 0 this is not defined, and at pi is also not defined, and then at minus pi is also not defined, then minus 2 pi is also not defined. Now can you say what is cot inverse of 0? Cot inverse of 0 will be equal to pi by 2. Then cot inverse of 1 will be equal to pi by 4. So graph of this function will be like this. So here also this will be like this. So this is the graph of a cot inverse function. I hope you understood all the 6 trigonometric ratios. Next onwards we will move to the problems. How to remember this one? The easiest way is, I told you that here the graphs are not important, but the domain and the range of the function, inverse functions are very important. Make 3 as one group, that is sine, reciprocal of that is cosec, and tan as one, because these 3 functions domain is depend on minus pi by 2 and pi by 2. Remaining 3 are 1, that is cos, reciprocal of that will be secant, and cot. These 3 are 1 because it is depend on the 0, pi.